There's $12 trillion of outstanding mortgage debt in the United States, and each and every single one of those mortgages represents a risk. We primarily focus on appraisal documents. In many cases, we've taken that 30-minute process down to sub 5 minutes. We solved the problem we wanted to solve, but we also maintained our speed and velocity. And I think for a startup who's trying to get things out into market, sometimes it's worth it to kind of step back, build yourself an internal tool, and then let yourself reap the benefits of that.
Hi, I'm Brett Gibson, and welcome to High Bit, a new podcast where we do deep dives on the art of problem solving with engineers and technical experts from our community of early stage startups. In today's episode, we're sitting down with my friend Vince Chu. Vince and I have worked together for many years, first at Posterous, where he was hired as our first engineer, and then later as a partner here at Initialized. Vince is now the co-founder and CTO of HomeVision, a startup providing comprehensive collateral underwriting powered by machine intelligence. The details of engineering problems fascinate me, but I'm just as interested in how the best engineers I know think, how they zoom in on which details matter the most, and then use that focus to navigate to elegant solutions. Join me on this journey as we discuss thorny engineering problems with my guests and get into the weeds about how they solve them. Hey Vince, welcome back to the office.
Yeah.
It's been a while. It's great to have you here again. Maybe for context for everybody, you can talk us through, how you used to work here and how the ways we worked together in the past.
Well, it's kind of funny because I've known you now, Brett, since I want to say 2009, maybe back, working when I
over
was just
the Avalon or
whatever
whatever Gary's apartment building was by the Caltrain.
Yeah, exactly. I mean, it's interesting because I really feel like I've had a charmed career working not just with you, but with a bunch of interesting folks. And, I think it just starts with my needing a job after grad school and not being able to find one as a physicist in the Great Recession, and kind of making my way working with Gary, Sachin, and yourself at Posterous. I always like to say that you taught me pretty much everything I know about engineering. Was spent just kind of watching you at Posterous, just kind of build all these things. And that was an amazing experience that I think was really the start of my career. But then, after working with you at Posterous, we got a chance to work together again at Initialized, but this time on the opposite side.
I came and worked on your code that time.
I know. Hopefully my code wasn't really crappy and it was actually a reasonable code. Spent a lot of time learning the ropes around investing and understanding and seeing a lot of startups across the broad spectrum. And I think that was really valuable experience that, I felt like I was able to get here Initialized with you. And it's really cool to see that, you're running the place now. So it's amazing.
Thanks. Awesome. Well, maybe we can start off by telling us what you're working on these days.
I'm the co-founder and CTO of HomeVision. We work primarily in mortgage underwriting, but we power collateral underwriting, which really requires a lot of different technologies to help automate and streamline the process of assessing and underwriting collateral, which is what underpins the $12 billion mortgage market, really. And to do so, you really need to have to bring together a diverse group of individuals, people from the industry, people from tech, good product people, to really bring together modern technology, computer vision, machine learning, natural language processing, to help bring a lot of automation to this industry.
That's awesome. And so maybe take a second, tell us what got you to go back to starting a startup?
I mean, we always joke that, kind of it's just a little like Hotel California, you can't really check out once you're in. But honestly, ultimately, I love building things. And I also love building things, I think, in industries that have been traditionally less tech forward. I love that process of working with people that are experts and pros in their industry, but that don't necessarily have the same access to technology that you might have working inside of Meta or Google or the newest AI startup. I really love that process of understanding their needs and kind of bringing modern, cutting edge technology to their problems and solving them. So I always joke that I was built to build an enterprise SaaS company.
Yeah. Gary used to always talk about file cabinet industries and how they were switching over to software. And it was eating everything. And I feel like that trend is on steroids with AI technology.
Trend is on steroids. Like, things are changing so quickly these days, and I think if you're not a little paranoid about what's happening, what's coming for different industries in the future, I think you just have to stay on top of that stuff and really be focused on it. The pace of change only grows quicker, and I think you'll see a lot of industries either trying to acquire this technology, build it themselves, or honestly working with startups to satisfy those needs. And I think that's where we come in.
Yeah, I mean, it also resonates just building things again too. I remember, when I joined the firm, you and I were writing a lot of software together, and I miss that part of it.
Well, I mean, it's kind of interesting because Initialized, I thought, always was one of those people, one of those venture firms that really had software at the heart of it. I mean, if you just look at all the people, all the partners, primarily product designers, product managers, engineers like ourselves, really understood how tech was transformative, and it was a really cool place to be, building all of that software with you and with other folks.
Yeah. Okay, and so I guess starting off, like, when you think about technical problems at HomeVision, what's hard about the problem at the highest level?
I mean, I think at the highest level, we're essentially trying to teach a computer how to read. And anyone who's ever tried to get computers to do anything realizes just how difficult of a challenge that is. And I think particularly for the types of documents that we process, they're enormously complex. They're not just structured documents, but they have free-form text. They have photos of the interior of the home, photos of the exterior of the home, maps, sketches, and floor plans. And it's a real testament to human intelligence that you can just hand one of these documents to a human being, give them some training, and generally a lot of them can read it, understand it, pick out inconsistencies. They can scrub it against policy and checklists, and with some additional training, do some really nuanced analysis. And so how do you teach a computer to replicate all of that? It's a really tough trick to pull off, and one that obviously we have spent a lot of the last couple of years focused on. And really, to do that, you really need to bring together a lot of disparate technologies and make them work well together. And so it's not just, I think, in the traditional machine learning sense, sort of like a classification problem, an object detection problem. It's actually all of those problems put together in a format that humans can understand and interpret.
Maybe say more about the actual document you're ingesting for people. Is it, what is it? Is it standardized at all?
So just backing up a little bit, the mortgage is really a piece of data. It's a package of data. There's $12 trillion of outstanding mortgage debt in the United States. And each and every single one of those mortgages represents a risk. And, I don't think I have to repeat what happens when that risk kind of goes off the rails. And humans actually are in charge of making those risk decisions about whether or not the borrower can repay, whether or not the collateral that underpins the loan is good collateral for this loan. And so for us, we primarily focus on appraisal documents. This really goes to justifying whether or not the home that serves as the collateral supports the size of the loan. And to do so, the document is not super standardized. It's a 50-page document that has a structured kind of form piece of it, but also a lot of unstructured commentary about the market, about influences that the home have, positive or negative. Is it located near a busy road? Is it located in a good school district? Does it have any potential signs of bias? Substantiating the report as well are photos of the interior of the property, photos of the exterior of the property, the surroundings. And all these things have to be checked about the report so that the home and the collateral are well substantiated and you have a loan that can ultimately be sold to the capital markets. And so what we do is try to inspect everything about the property based on the report. So trying to detect things like damage or the condition of the property from the photos. Pick up if there's any analysis that is hanging. If there's any trouble signs, whether or not the home sits against a busy road and how that should be reflected in the value of the homes. We also pull in a lot of external data sources to verify and validate what the home appraiser has said about the home. And we do this in a largely automated fashion, but we also bring in humans when needed. And so that combination has led to a lot of automation in our field. And we have clients that used to spend 20 to 30, upwards of 40 minutes double checking, reading, scanning, doing what we call stare and compare, where they literally stare at the document and compare it against other known pieces of information. In many cases, we've taken that 30-minute process down to sub 5 minutes. And that's something that has really been the product of the team's hard work. But ultimately, as I said, we taught a computer how to read at the end of the day.
Yeah, I mean, it's beyond reading, because it's just like I bought a home a few years ago, and I remember looking at listings, and you kind of have some sense for like price per square footage in an area, but someone who's like a professional realtor has a lot closer read on all the variables that might go into how a house might price. And it almost, for someone who's untrained, it seems a little like alchemy.
I think one of the things that we've found is that really to build trust, you need to really bring humans into the process. Like, you can't just take them completely out of the process and say, hey, look, you're going to be a passive observer, and you're not going to have any visibility or any understanding about how this thing works. And kind of the analogy I like to use is that, when Betty Crocker first released their instant cake mix, it was literally just like dump the bag into a bowl, throw some water in, and then bake the thing. And honestly, people rebelled against that. They wanted to feel and have some control of the process. And even what they found is something as simple as cracking an egg and mixing it gave them a lot more of an understanding about what was happening and made them feel better about the product. And I think that analogy, there's some truth in that, especially when we're asking humans to trust the results of automation.
Yeah, that's a great anecdote. I mean, a lot of the things are just kind of like, technology can be fundamentally scary to people. And so there's this aspect of like bringing everyone along for the ride in a way that makes them feel good.
There's a lot of regulatory requirements too, as well. And I think that's one of the difficult things about working in sort of these file cabinet businesses, is that you as a product builder, as an engineer, you can't just get away with having good tech. You actually have to really understand the regulatory environment, what counts for good work, and what really satisfies the market need. And in this case, for us, what ultimately constitutes an asset that can be sold to the capital markets.
And what actually is the output of this process? Are you like validating against a number somebody's already come up with? Or are you coming up with a number? Are you giving up like error bars or something?
So it's kind of interesting. I think from an outsider's perspective, you think of what is a home worth, and you're like, well, somebody's willing to buy it for X. Isn't it by definition what it's worth? And the truth of the matter is that the number of what the home is worth is just where the process begins. Because what people who are buying and selling loans want to know is how that number was arrived at. What factors contributed to that number? Was the home in a good location, a bad location? Did it have damage? Is it new? Is it of high quality? So it's really a multifactorial analysis. And ultimately what is produced is not just the report, but a substantiation of that report. An analysis, almost like a meta-analysis of all the things that went into that decision and whether or not those decision points in that analysis is well substantiated. And I think that's the difficult part about it. It's not just the number, what is this home worth? It's how you arrived at that, and is that reasoning sound?
Okay. All right. So, and then from an engineering standpoint, you have this document. It's lengthy. It's full of text. It's full of probably bad scans and images and all sorts of random things. And you have to output something that's fairly nuanced in its own right. So where did you start? What did you think? Was it immediately clear to you how to break this problem down?
Yeah. So, when we started, we actually started on a completely different problem in this space. And we figured out very quickly that the product that we were working on wasn't going to scale, not at least as quickly as we wanted. But what we actually figured out was that there was a real appetite to replace human labor in our industry, which is mortgage underwriting writ largely. The challenge is there, though, is that you really do have to understand these documents in a really difficult way. So we kind of proceeded as you do in a startup by building kind of just the very minimal thing. It was really at the time just something that would decompose a document into text, do some lightweight classification based on what it saw in the text, and it was just really simple. In fact, it ran completely on the web server, which is kind of hacky and gross and disgusting.
Like during the request?
During the request, in line. And honestly, it was not that sophisticated or that nuanced, but it actually fulfilled a need because it could begin the process of helping organize and contextualize these decisions, like this data, for people that were just whose productivity tool was essentially Acrobat.
Mm-hmm.
So it was completely unassisted, and we found a lot of people really liked what we were doing, really liked the process of structuring the data, organizing it, when possible, making some lightweight decisions and things like that. And so that actually started to take off and receive quite a positive reaction. So we were like, we're onto something. And so we kind of started iterating and building and pulling more things. We pulled in photo models into it. We started doing more and more things with NLP. Up to the point where it started getting really slow, and our web servers were honestly just kind of starting to bog down with all the load. So we kind of moved it off and started engineering it. But ultimately it just started dragging and taking quite a long time. And so that was our first signal that we probably needed to do something a little different. But it really started from that kernel of just fast iteration, getting things out into the market and into the hands of customers.
Okay. And so the first pass there weren't any fundamental computer science breakthroughs needed. It was just like, let's break down this problem. Let's make something useful.
Exactly.
Let's add layers of utility on this until you had, something that worked and people valued, but was not performing in a way that made sense in their workflows.
Yeah. And I think that's probably the genesis of, I think, any good idea, is that you really have to talk to people. And, one of the things that we did early on as a team is we actually went and shadowed people. We went to mortgage lenders. We went to appraisal management companies. We watched people doing their work. We watched people 2 or 3 monitors with 4 or 5 different PDFs open, Outlook in one corner, Post-it notes on the desk, and just kind of staring and comparing, just staring at PDFs all day long. And, you have to really look at that and feel, man, what a waste. Like, technology really can help streamline and make this job a lot more, not just more, not just faster, but truthfully just more enjoyable. Because, it's pretty difficult work.
I mean, how big was your engineering team?
At the first version of this product, I went back and looked. The engineering team was really only 4 people, myself being one of them. So we had me, 3 other people in about 3 or 4 months, and we built a product that had its first paying customer, still have the check. We were paid by check. Still have that canceled check, or that deposited check. And that was the start. And, that was, I think, a pretty amazing experience to kind of just make just $1 on the internet. It's that moment where you're like, okay, I made something that people wanted and they're willing to pay me for it. That's how much they liked it.
Yeah, that's always so exciting. And then so you were like, you got to a point where from a user perspective, it was obvious that performance was an issue. And in fact, part of the user experience that you really need to dig into. And was it obvious to you what to do about that? Or was that like something you had to go try to spike on and figure out?
Yeah, I think, for sure. So, ultimately what happened was we started adding more and more functionality, which meant that the pipeline had to be first moved off of the web server into something that was a little more asynchronous. But then we just found that as that happened, we just kept adding more and more functionality. The pipeline kept getting longer and longer. People, started waiting from like 30 seconds for a result to a minute to 2 minutes to 3 minutes. And that's just honestly a really terrible experience, that someone is sitting there waiting for 3-4 minutes for something that they just need to do to complete their job. So we set off and we kicked off a process where we really looked at this pipeline with fine-grained detail. And we started doing what most people do, which is like, okay, well, what can we make concurrent? These two things don't depend on each other, so let's just run them concurrent. And we actually found what we were doing was kind of hand engineering these concurrency tasks. And when we needed to add other things, just kind of trying to slot them in manually. And it was really not just a painstaking process that really chewed up a lot of developer time. It was also really buggy.
Yeah, so like a whack-a-mole.
Yeah, it was like a whack-a-mole problem, because like you would decide, oh, I probably could move this thing over here, and so these two things could run concurrently. But then you would realize after you launched it that that thing had some subtle dependency that was now broken, and you had all sorts of bugs that were arising because of that. And that really led us as a team to just kind of step back and say, okay, what is the problem we're really trying to solve? We're trying to solve the obvious problem, which is to make this thing go fast because people don't want to wait. But the second kind of, I almost call it like a meta problem about this, is how do you support the next set of features that you want to build and get those features into the pipeline in a transparent way that maximizes developer efficiency. So what the developer has to think about is just implementation. And so what we ended up developing was this internal library we called libpipeline. And libpipeline is a bit of it's like a scheduler. And what it does is it figures out, based on the declared dependencies of all the things that you need to run, what is the optimal order that it should run things in. And so that did two things. One, it dramatically shrunk the processing time, because the scheduler knew how to run all these things concurrently, and so it was maximally or optimally concurrent, and that actually dramatically reduced the pipeline time down from like 3 or 4 minutes to, I think we're now just about like 90 seconds or less at a 99th percentile level, which was a pretty enormous achievement considering all the different things that have to happen to the document. But the second thing that actually happened was it created a framework that engineers could work within. If you are an engineer, you want to add this new feature or this new piece of the pipeline, all you have to do is declare what you depend on, what data you need, and the data would be delivered to your code, and you didn't have to take any effort to schedule it. The scheduler would just know all of a sudden what you needed to do and schedule it. And so that actually kicked off, I think, a real nice process where we could just support and expand the usages of this pipeline to all these different types of documents. You have a different type of document that needs a different set of features computed, no problem. Just mix and match your phases, we call them, and then the phases will just run maximally concurrent at maximum concurrency. So there was just these two nice effects, which is like we solved the problem we wanted to solve, but we also maintained our speed and velocity. And I think for a startup who's trying to get things out into market, sometimes it's worth it to kind of step back, build yourself an internal tool, and then let yourself kind of reap the benefits of that through faster iteration.
Yeah, I mean, because the first sort of core learning is it's unlike a lot of product types. There's no like removing or ignoring features. Like you need to be able to assess in every way that is relevant. Yeah. Everything a human kind of does, and so it always has to be kind of additive. Yeah,
it always has to be kind of additive, and you never want people to lose functionality. Yeah. And so this was a way for us to kind of square the circle.
I mean, what do you think would have happened if you had tried to do this from the onset? Do you think it would even occur to you, or
Yeah, I mean, I think in a perfect world we would have said, oh, this thing is going to be a thing, so we should spend the time now. But I think as with most people that are building under pressure and conditions of uncertainty, it's usually better to just throw something out there and get that feedback so that you don't waste too much time. But I think one of the things is, and this is, I think, like the difficult thing about engineering inside of a startup, is that you do need to step back periodically and say, hey, this is something that we'll need to support, or from a strategic perspective, we'll probably need to do a bunch of these things. Yeah. So what will an idealized version of this look like, and what capabilities might that open up, and does that actually put the business, the company, in a good place? And if the answer is yes, it's usually best to kind of step back and do that. And that requires, I think, engineers and product people to work together with, I guess, like, with an eye towards the future, which is always difficult in a startup. It's not always easy to kind of take time away from building features to kind of go off on this side quest.
Yeah. I mean, it's always a nuanced question generally, either like to work on architecture or tech debt, because on one hand, it can make you run faster at the other end, but the other, it doesn't feel like you're solving a user need. And sometimes the abstraction is best after you have the example.
Yeah, I think you never want to build these abstractions in a vacuum, because then you almost kind of get into the realm of just like very theoretical debates about what matters, what doesn't. But I think if you have even that single N of one or N of two, oftentimes that's enough information to kind of set out the ground rules for what the abstraction has to do. But I'm personally a huge fan of devoting I think a reasonably huge amount of resourcing towards building frameworks, internal tools, more abstraction, because it tends to help us run more quickly. And it also is a great way to communicate, is if you have a tool or you have a framework, engineers will just slot into it, because generally they're lazy, so they just look at what's been done, and if it's been done in a framework, they'll just adopt it almost naturally.
Yeah, it's an interesting use case, because you had an obvious point to do it, because it was like the bottleneck was very clear, like this is just too slow for people. But and you'd also probably learned a lot about the level of modularity that was required for this task anyway.
I guess other tools that I think have been really enormously successful for us in the past is, we've built everything from deploy tools to metrics and monitoring. And deploy tooling is one of the favorite things I have to build. I always build it. One of the first things I always build in a startup or in a company or on a team is deploy tools, just because they're so leveraging. One of the things that I always look at is, if you can deploy it via Slack, you have a good deploy tool, because it just lowers the cost of deploying. You don't want to ever be in a position where people are uncomfortable to deploy. Like only Joe can deploy because he has the right combination of dependencies and libraries on his system, because then that just slows everybody down.
Yeah. And I assume the modularity you ended up with, but help both with, like isolation of fixing things, which gives you more confidence around deploying, and metrics, because then you can measure individual processes and how slow or fast and how they affected the whole.
Exactly. Because once everything is in a phase and once everything conforms to that interface, it's really easy to instrument and metric everything. And that gives you so much more situational awareness about what you need to improve and why.
Awesome. Yeah, I think there's a lot of actually interesting lessons in there, but about how to break things down and proceed. I guess maybe switch. Like, what do you think? When you look at like what's going on in the AI landscape, do you think that any of these processes you're working on are going to be fundamentally changed? Do you think it's just going to be more day-to-day engineering of plumbing things together? Like what is on your radar from a tech perspective?
I mean, the pace of change, especially with tools like large language models and just machine learning and deep learning in general, has been incredible in the last 5 years. I even think about what some of the things that we do would be impossible even 3 or 4 years ago, just because the technology doesn't exist. And I think one of the notable things about this recent machine learning, LLMs and deep learning is that it's taking place mostly in the open. You have foundational models that are being released that represent hundreds of millions, maybe even billions of dollars worth of collective training cost, and you can just use them. Sometimes by literally downloading the weights or retraining or the model architectures are all on Archive and on Hugging Face. And that's, I think, it's like a really enormously leveraging situation that we're in, when you don't have to ask for permission, when these things aren't necessarily locked back. I think one of the interesting things that I don't think the industry has necessarily solved is, how do you work with these models in the context of a real product? And in my personal lens, because we work in spaces where people are fundamentally trying to judge, assess, and manage risk, is that, again, the story starts when you have a model that has a certain level of statistical performance. But that's literally where the story starts. Because ultimately, for you to deploy that model, for you to use it effectively, and for you to really solve a customer need, you need to actually have humans in that system, understanding the results of the output, feeling comfortable, making sure that the outputs are interpretable, transparent, because ultimately that person is making a decision on behalf of the company, or maybe for their own selves, their own licensing could be at stake. They're making those risk decisions. And if the model doesn't get humans comfortable with its results, it's just not going to work.
Yeah. Yeah, that's really interesting. And we were talking a little bit about that before, about how, I mean, it's interesting because it's like immediately obvious to you that there's something different about how humans perceive self-driving car safety versus automatic safety, Exactly. But it applies to all domains. This idea that we're okay with hiring humans to do things with probabilistic quality results, but we expect machines to be more deterministic.
Yeah.
And so as we're layering in machine work that's actually fundamentally probabilistic, it's scary everywhere.
It's scary. And I think, my take on it ultimately is that in these human systems, and these are human systems, right? Somebody has to take the risk. Mm-hmm. Some entity, and even if you think about it, even outside of the abstract, somebody at that company has to take some risk or liability. And it's not enough in most cases to simply say, well, we verified this thing statistically. It's a black box, but it seems to work at 99, 99.9, 99.99, whatever percent accuracy. That's great that you have a model that can do these things. But ultimately, again, you need the buy-in of people, not just decision makers, but people who work in the system every day, who are ultimately responsible for these outputs. You need to build products and services and engineering interfaces that make people comfortable, quite frankly, with taking on that risk and deferring some aspect of their risk taking to a model or to automation. Yeah. And that's a difficult challenge, because it's fundamentally a human one.
Yeah, it's a social problem and not a technical one. Yeah. And we are okay with humans failing because we're used to forgiving humans. We're not okay with humans deploying machines that fail, because that's weird. And I think it's interesting to hear you talk about how important it is for you to be, I guess, empathetic to that mentality as you're deploying software.
Yeah, and I think you can, as a technologist, kind of just take the hardline technology view.
Works on my machine.
It works to some level of statistical characterization.
But that's always been the failure mode in engineering. I remember that it came up at Posterous. So it'd be people like at Posterous, we were very adamant about everyone doing support, because it wasn't just like just because it works for you. The user, if it fails for the user, they're right. Right, they're correct that it failed for them.
And I think that's kind of like the difference between having a neat demo to something that people are willing to literally stake their jobs on. Mm-hmm. You need to go that extra level, and I think even in our own work, we found all sorts of ways to make humans trust the results, and it usually comes down to just having more transparency. What inputs are going into the model? What inputs are causing the model to skew one way or the other? And for us, we make, it sounds really, really simple, but anytime we do any sort of image processing or computer vision or natural language processing, we always highlight parts of the report that went in to the model and why. We always highlight the things that we think are causing the model to make this decision. And ultimately that breeds a lot of trust with the user. And I think that's a lesson that I think is broadly applicable to anybody who is building in these spaces around automation or efficiency, is you ultimately need to have the products work for the users and not just simply thinking about it as we're replacing the user.
Yeah, and for in the more holistic sense of them and how they come to things.
Exactly.
Awesome. What should we be looking forward to from HomeVision?
Yeah, so this year I think has been a really amazing year. We grew the business despite the fact that the mortgage industry was off by 50% in terms of volume. So I think for us this year is all about scaling and working with some of the largest lenders in the country and really being a pioneer for bringing in much more automation to mortgage underwriting more generally.
That's great. Awesome. Well, this has been a lot of fun.
Yeah,
Thanks a lot for coming
by. Good to be back. Thanks, Brett. Really appreciate it.
That's it for this episode with Vince Chu, co-founder and CTO of HomeVision. On the next episode of HiBit, we sit down with Ben Chelf and John Boyles from Soul, a startup building the world's first wearable e-reader. HiBit is produced by Initialized Capital. Our showrunner is Candy Chang. Our videographer and editor is Kevin Heintz. And I'm Brett Gibson. Thanks for listening.